Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter. This is episode 10, so we've been doing a little bit of work so far, and we're ready to run multi-line programs, or we're ready to force ourselves to get ready to run multi-line programs, maybe more accurately. All right, let's go to the IDE. So let's see. The way we work now, we maintain a program structure. If I can find it. Program. Okay. And basically it's a map of int to string, so it's the line to the line number to the contents of the line. If you recall, BASIC has line numbers on each line. And right now we can execute one line of code, but we can't execute, normally it just executes one line and then falls through to the next line and the next line and the next line, like many programming languages. And we don't manage that yet. So one thing I thought I would do is add this notion of an end statement. The original BASIC from like 1964 required you to have an end statement. Most BASICs, maybe even that one, if you omit it, they just run off the end of the program and it's fine. So I don't know, maybe, do we need that to do it? I don't know. But I think, well, what I think to run off the end, we need to kind of implicitly stop. So I think we'll define the end statement and use that if we try and get something out of the range of the program, or we're falling off the end, as it were, then we'll return that statement and run it, which will stop the interpreter. Right now we don't even loop or attempt to run multiple statements, so it's not an issue. Okay. Now, I probably should have gone back to my picture here, but the general structure of an interpreter, it starts out looking like a compiler. You feed in program text, it does scanning, lexing, lexical analysis, however you like to call it, producing a stream of tokens, and that gets analyzed into trees of nodes through syntax analysis or parsing. And then those tree of nodes, in a compiler, you would use those to generate code. In an interpreter, you just interpret each node directly, okay? So when we add a new feature, a new statement type anyway, we have to make sure we can scan it, match the tokens in it and parse it, okay? Now the end statement is as simple as they come. It's the word end on a line by itself. So there's not a lot to do there. Our lexer, we've already added something for all the keywords. So we have a keyword.end. Well, the keyword end maps to our token.end. Now the parser, if I can find it. Okay, I try and keep the test on the left for what it's worth. All right, the parser, let's go down single line. Okay, so how does it match one line? Well, it looks for the integer at the start of the line, and if it finds it, it then tries to parse the statement. Okay, and now statements, where everything's interesting. Okay, well, we've already done the end. Okay, I guess we're further than I thought. So if you see the end token, then we skip over that and we say, okay, the result is parse.end. All right, and then finally interpreter. Okay, here we don't do anything yet. Excuse me one sec. I'm going to be running off for water before too long, I'm afraid. All right, so let's get to interpreter tests. Or maybe just, yeah. Excuse me. I think even BASIC tests, BASIC's kind of the program level. Interpreter tests, they check one node type at a time. So we build up a line with the node type in it. I guess we could do that. But yeah, but I think BASIC's a fine level. BASIC, you work at the program level, and so I'm sort of doing a high level testing through, as it were. Okay, test end, and the program, we're just gonna make it be program. Oops. 999 end. Now, what should be our, well, I think we're going to have to add something else to the interpreter. So right now, run just runs step, which runs one line. Okay. What we would like to do is we need some sort of loop. Okay. And you're going to loop until done. Okay. So we expect the end to mark this program as being done. And I think we'll maintain that as state in the interpreter. Okay, so the state here, we've got the program and the line number, okay, which is like the current line. But I think we need a state done, and then we start out false. Okay. Usually a Boolean's not a great sign, but that's what we got. All right, so interpreter dot done, and let's just say assert true. Okay, so all right, he's just not caught up yet. All right, let's see. So if we have done false, nothing ever sets it true, then we don't expect this to pass. So let's run the test and make sure. And probably, I'm not looking at output, so it'll complain about that. Ooh. No member of type done. Oh. Oh, interesting. Basie really, I don't know if this Basie used to do a bit more, and I think maybe it's not pulling its weight at this point. All right, let's do interpreter.interpreter for now. And we'll do some cleanup. Yeah, there we go. And we expect it to fail, of course. Oh, first test of the day. Okay, there we go. And there's really only one choice, assert true failed. Okay, so let's get green first, and then we'll clean up some. All right, so all we want to do when the end line is done, we're just gonna, well, we need to set our flag. Done equals true, and we're gonna return the output, whatever they had so far. I'm still not happy about output, but we'll fix that later. I'm not looking at the output. Now, some of these basics, I think they print done at the end or something like that. We could do that, but for now it's not. All right, I think this will pass. Okay, and let's push that. End statement. Okay. Let's see. So I guess I want to, well, let's take a look here. I'm going to say while not done, do something. I guess that's okay in my run at some future stage. I could flip the logic and say, well, I'll continue executing. But I think this is okay. Not much to it, so I'm okay with that. Let's find that Basie again. Okay, so what I'd like to do is I'd like to anybody who's calling this, I want to get rid of that and inline the class basically. I don't know how much we have. Well, the REPL does. Okay. Interpreter equals basis of program. Okay, so let's just make an interpreter. It's got the same methods. Interpreter equals interpreter of program. Okay, and let's am I doing anything funny there? Basis of program is just interpreter subprogram. Okay, I think that's acceptable. Where's these tests? Okay. So anybody who says BASI, I'm just going to say interpreter. I'm trying to get just out of my vocabulary and I'm not succeeding very well. I don't know if I can refresh that somehow. Okay, I still mentioned BASI tests. BASI app, that's different. Okay, let's run all tests, which I guess I should have done before. I think the REPL got part of what was in BASI before, and the interpreter had the rest, so there's just not enough for it to do. All right, now let's take this one out. Delete. Okay. Okay. Now, BASI tests, I want to rename that. Well, I really just want to let's copy these out. Actually, I don't need that much. We'll just make them interpreter tests. Blend them in here. They're starting off with REM and stuff, so they're pretty basic as well. That's a little more operator stuff. Okay. Oh, I got two versions of this. And this one's the tree. And this one's code. Okay, let's do the tree first. Okay, so my new tests should all run. Okay. And I don't know, I've been burnt by deleting stuff and renaming and things like that. So I'm being stepwise here. Okay. So end statement is done. All right. Now, multi-line programs. This one, the problem is, okay, and this may be, I don't know. So this structure, so if I compare what the old interpreters would do, I think what they I think what they would do is when you wrote your program, I think they translated it to, I'm not sure. I think it's maybe sort of a standard line format. Um, I don't know what exactly they did, but I suspect somewhere the bulk of the program was just a chunk, a large string kind of thing, and we've gotten away from that by making this map. The nice thing about the string is if you're on this line and you just do a fall through, all you do is find the next new line going forward and then start at the next line. And so you're scanning it's almost a fallout of your scanning that you've skipped forward, to read the line, you have to read the whole line. At that point, you just passed the new line, you're sitting there on the next line, and you could pick up from there. In this structure, you're on line 17, you don't know the next line. It could be 18, it could be 25, it could be the last line. So there's kind of an ambiguity there. And I don't mind. Well, I don't mind that you're doing some searching or something like that to get there. I mean, that's I don't know. It seems you do a lot worse stuff. And the old interpreters ended up doing some worse stuff than that, scanning. I mean, I think for GOTO they just scan the text and look for the next line that, has that target number. But I think what we're going to have to do, uh, well, we can look up a given line. That's fine. We can get all the lines. Okay. We can get the first line number. I think what we want to do is, I think given a line number, we want to get the next line number successively. Okay, which we could do by going through and pulling it out from the keys, which is probably reasonable enough. You find the index of the current line, and if there's something at the succeeding index, then you return that. Otherwise, you're out of range and you return nil or something like that. I think is moderately reasonable. Although I think we could actually return a dummy end statement would be a better way to go. But something like that. The other one we have to do is, well, a GOTO, we're just gonna look it up and go to it. So there's no issue there. It's really this falling off the end kind of thing, or the falling to the next slide. Okay, so I don't know. I'm kind of jumping in the middle here. Like maybe we should let's see our run. We get the line number, we parse the line, we step. Okay. Now at the next point, we should know the next line number, and if we're not done, we should go back to the top and keep going. Okay, so trying to think what's a good way to get this tested in. I guess if I fed in a program with one line, what would happen? This handles it now. So if I feed in two lines, print 17 and end, what happens. Okay, well, let's try that. I think that's a reasonable enough test. And this is getting long, so I'm a little worried there, but okay, so func test 2-line program runs both lines. And that's going to look more like our these kind of tests. So let's do this. Borrow that. Let's try that again. Okay. So if our program is 25 print 25, let's do this. Forty print 40. Okay, multi-line. We interpret that thing and we run it. The output should equal 25 new line, 40 new line. Okay, I think we can be pretty sure it won't. I guess I'll run the class while it finds it. Okay, yeah, no surprise down there. We expect it just got 25 because it only runs one line. Yeah, okay. Yeah, but then falling off the end, how's that going to work? Let's do a different test. Let's do 40 end. I think I can kind of fake it in. All right, let's. Sorry, this should be different. Yeah, so it's in a green state, but it's kind of by accident, as it were. But let's make this go. Okay, so we get the starting line number from the run, which maybe that's not the right place. I don't know. We get the starting line number. We parse the line. We run step. Let's split this up. Okay. And this says start with empty output. So let's let result equal empty. And then do that. Okay, so the output's a function of the output. Maybe output would be a better name, wouldn't it? Okay, so I'll split this out. All right, so we run the program line number var. Okay, and we return that. Now we got to put the repeat in somewhere. Well, if we're done, if we're not done, I don't know. Can I just write this? I think I can. Well, not done. Do that. Okay, so we're not done to start with. Done is false, not done is true. So while true, we're going to get the current line number, parse it, append to the output, come back around. Well, this loop should get an infinite loop. Okay, looks infinite to me. All right. that was the same process they use in calculus. You slice everything up into infinitely small pieces and add them up. But we need to do something to move on to the next line. How should that happen? I mean, it would be natural enough. I could do it here. Let's do that. Let's do line number equals 40. Okay. Now, why I'm doing it here is I'm grabbing this line and then I'm saying fall through by default, and then I run the line. If running it is a GOTO, well, it changes that target. So by the time I get back around, I'm doing that, is my claim. Let's run this again. It should work this time. Well, so much for that. Line number equals 40. Okay, now I am puzzled. All right, so I do 25, print 25. So we get the line, print 25, set the line number to 40. We parse print 25. We run print 25. Come back around. We're not done. Line equals program sub line number should be 40. Oh. Well, no, that should be okay. It's line 40 is end. We say go to line 40 next. Parse end, run end, done should become false. Okay, so let's break here and see what's happening. All right, so if I step over, the line is 25 print. Oh, interesting. I really would have thought line should be just the front of that. Let's see what's going on. Okay. Oops. Parse. Oh. Common timeout waiting for updates to re-enable. I don't know what that means. The parse is not looking good though. Oh, I don't know why it's 0 there. Excuse me. 25 print one value number 25. Okay, that looks okay. Step over and the output is 25. Okay, so that's okay. Step over. Line number's 40. Line. Oh, empty. Okay. I think. All right, let me back up here. When you do program, let's see our other programs. I don't know if I maybe, no. I think maybe our end statement, oh, the interpreter's fine. Something about our parser. I thought we did next token. We skipped the next token. Return result. Okay, let's back up. Actually, maybe look at program. Okay, so program, you initialize it with, this is really a oh, I'm not initializing it correctly, I guess. Line that count is 0, line prefix is number, program subint. Oh, I need to feed the lines in one at a time. This is not designed to. Interesting. So, because this is supporting the editor, primitive as it is, you can get and set, but I don't have a constructor that takes a program. I have a constructor that takes one line. Interesting. I don't even know if anybody calls. Let's find program. Now that can't be right. References in project, ignoring case. Somebody uses this. Symbol in workspace. Oh yeah, you mean this program? Okay. Program. I'm looking for constructor calls. Interpreter. No, interpreter should be the REPL. Yeah. Okay, so the REPL, yeah, never calls program with anything in it. Actually, nobody does. Okay. Is that true? These guys do. They've always done one line at a time because we've never supported two lines. Okay, so I think let's set this test aside. It was an interpreter test. Okay, down at the bottom. And my version of set aside is that. I don't think there's an add ignore kind of thing. But I think we want to make our program sophisticated enough to do this. All right. And it's not. I think, well, let's just take this for an example and find some program tests. Okay. Okay, so we're going to initialize a multi-line program, and we should assert equal program sub 25 is 25 print 25. New line, I think. And program sub 40 should be 40 end. Okay. And I certainly believe this will fail. And yeah, my first clue. Oh, interesting. Why two? Oh, two assertions. Okay. Yeah, so I think this is going to be 25 print, 40 end. Yeah, so it didn't split the lines. And that looked suspicious to me before, so I should have pursued that suspicion. All right, so I think what we want to say is there's a normal init that does nothing. And this default goes away. Okay, and let's try that. That doesn't change anything. It's just confirming things. Or have I messed things up? Test 10 rem. Maybe I shouldn't run that while I'm in the middle of this other. Ugh, okay. Let's get this thing straightened out. Program. Okay. So what I want to do is lines of string. Excuse me. Okay. Okay. Unfortunately, you're not dealing with strings. Oh. Don't need that if I do that. Consecutive statements. Sorry, wrong language. Okay. So if you call the initializer with a bunch of lines, it digs out the line number on each line and stores it. Okay. So I think program should be okay. What do I know? Okay. Expound nil while wrapping a line. How is that possible? Just spaces. Are we in this one? Sequence. Okay, we are. Let me break here and just run this one test. All right, make sure lines is what we expect. Oh, lines for each. I need to do lines.split. Okay, try that again. Yeah, see they I don't know how this slice is working. Maybe this is I don't know how this is working. not working? .25 print new line. Oh, we do strip off. Okay. Okay, let's try them all. I don't know why. Okay. 10 rem. I think my interpreter loop is screwing things up. Okay, let's take the loop out. Okay, so we make program able to handle multi-line programs. All right, and then I think our interpreter test is where we want to go next. So if I take this off, I think our test is going to run a little better. The other ones probably will fail, so let's do a build. Okay, run that. Should fail. No, actually it won't fail because it'll just run 25. Okay, so it prints the 25 and there's no loop, so it doesn't stop. So now let me try this. So this only works for this program because it has the line 40 end. So while not done, we'll look up line 25, should be print 25. We'll say the next line should be 40. We'll parse 25 print. We'll print 25. Come back around, not done is still true. Look, program subline number, line 40 should be an end. Next line is 40. Ooh, that's dangerous. Parse out a line. That's the end. We run the end. It sets the done flag to done, and it should be done. All right, so this should be green still. And everything else should break. Somewhere in infinite loop. Okay, there's that infinite loop. All right, well, that's a good place to be. We can work with this. Let's take a break, like a 3-minute break. I'll get myself a drink, and we'll go ahead and come back and get this loop working properly. Welcome back. All right. So I think I think I'm driving my requirements out through this loop is what's going on here. So we mentioned before, like program really, we want to ask program next line number after the current line number. Okay. And to make all these others work, all right. I think I'm going to comment this again. Okay. And everything should work, I think, right? But this 40 is coming from our test case. I want this to be program.next line for line number. And that's a question for program. Where's program tests over here? Yeah. It's a question for program. Okay, so let's start easy. So test unknown next line number is, let's say 0. Okay, and So the program almost doesn't matter. Yeah, it really, even an empty program, right? Um, if you say program.next from line number 10, we expect that to be 0. I think this is next line, maybe for 10. Following line, next line, line after. Line after 10 is 0. Okay, I think that's true. Doesn't exist. We don't have a mechanism here. Okay, so this is function line after. You give it a line number of int, and it returns an int. And let's just return -1. Make sure everything's linked right. Should fail, of course. Okay, let's return 0. And actually, I think I want to make this be end. Can I do that? If you say program sub 0, you should get 0 end. We can make it look like that. Okay, so I'm putting a little bit different requirement on. All right. How did that pass? We don't do that already, do we? If int new value equals nil, okay. Remove key. Wait a minute. Program sub 0 get program sub line number or empty string. How does that match? Okay. Sure looks like an empty string. How did you match that? Assert equal. Okay. Line. Let's do it again. The empty string, I believe. Okay, print line. Got spelled exactly right. It's not helping me any. Print. That probably would make a difference. Line 0 end. That's what I expected. Oh, maybe I just need to continue. Yeah, okay. This test should fail. Okay, good. All right. If I don't know the line number, I'm saying it should be, let's say, default line. A little bit of a sentinel kind of thing again. Now, it's not really legal basic to do line 0 end. I don't think you can have a line 0, but okay. So that's fine so far. This is not correct though. Line after, yeah, okay, but let's prove this isn't right. Well, the 0 is probably okay. I don't know. The test is, I guess, line after first line is second line. Line after 10 should be 20. Okay, and that will certainly fail. Now, I don't know. This is where I think yeah, the list of keys, maybe I've got to deal with that. I don't know if there's an easier way, but I could sort the line numbers. I could extract the line numbers, which are the keys, sort them, and find the index of the current line. And if that's not there, it's 0. And if take the entry after it. Does this justify that? I think it does. That first one's a little bit of a lie because the line after 10, when there is no 10, you're going to have to deal with that case. So I'm maybe dealing with two cases. But let's take program.keys.sorted by, and then just less than. Okay. Let keys equal that. Okay, so now I have this list of keys. If fair enough. No, that's a let. Okay. Let start index equal keys dot index search find first index where. No, I want the index. Yeah. keys dot for first index where well, I guess I can where oh, good morning or afternoon. Let's see. So we're doing some work on the program to try and figure out what the next line number is. All right. So if I look up, I'm gonna have to look up first index and figure this thing out. First index where? Okay, so we get an element which is key value. Okay. So we get key value in, and we're going to find it where key equals line number. Is that right? Can I cover it empty? Expects one argument, but two were used. Dictionary.keys.element. Oh, I just have the keys. Yes. Okay, so let's simplify. Is that the right? Okay, and I just have to find first index and figure out what it's doing when it fails. I think it's optional. Yeah. Turns the last element. Okay, so I get the keys. I guess it's returning the index or nil. Okay, so program. Okay, so if the starting index is nil, that means we didn't even find the line we're looking for. So if start index equals nil, then we return 0. Okay. Otherwise, if we want to look at start index plus 1, let next line equal keys dot keys sub start index plus 1, and I don't know what that does. Okay, I think I can force it because we've already checked that it's not nil. And I don't know in the subscript. Swift collection array. Okay, let's find subscript. Let's find subscript parent. Oh, it returns an index. Okay. All right, so we'll have to flip around. If well, if the I guess if the index, if start index is the same as keys dot count. In other words, our index was the last line found, then we return 0. Otherwise, we know it's, I guess we could say greater than or equal, just to convince ourselves that it's less than. So keys plus 1 should be legit. And then we'll return that value. Excuse me. Okay. This is more work than I wanted it to be, for sure. Okay. So we get the keys, the integer line numbers. We find the first one where the line number matches. Okay. If there is no line number in there, like in this case, it's just going to return 0. If the start index is too big, I guess we should have a different case then. Let's put this one in. Whoops. Let's do the one-line program. This should be 0. Okay. So I guess if I omitted this test, that second function should fail. Okay, let's see how we're doing. Oh, I duplicated that. Line after only line is 0 end. Okay. Okay. So that one blows up. All right. So let's take this back in. And I'll make sure the right test was blowing up. Test main, run test. Well, which test case are you? Test line after line, only line. Okay, yes. All right, let's run this again. All three of these should pass. Do I have a breakpoint? No. Which test are we on? Line after only line is 0. Index out of range. How are you out of range here? Oh. Start index is 0. If start index is nil, okay, and then print keys is 10. Okay, the start index is 0. Oh, I'm off by 1, I think. Okay, if it equals, oh boy, okay. If start index plus 1, I guess start index, if it equals keys dot count plus 1 minus 1. Keys dot count is 1. Start index is 0. And I want this to fail. So start index, I guess if I say it's start index plus 1, I think I'm going to be. Because now, wait, start index plus 1 is equal to keys dot count. If start index is 1 and I've got 1, then I've got a problem. If it's greater, then I've got more of a problem. Um, I guess I was saying if start index equals keys.count minus 1. Is that really what I'm saying here? Okay, if start index equals keys.count minus 1. So if I have 5 entries, I'm on line entry 4. Start index is 4. Keys.count minus 1 is 4. Then I've got 0. Okay. So now I'm going to manipulate this because I'm saying plus 1 in the next line. I kind of want to say plus 1 over here. Okay. If start index plus 1 equals keys.count, then I was at the last entry and I should return 0. Okay. And then I proved it was safe to access because it's less than keys.count. I guess I could say greater or equal. I know it's less than keys.count, so it should be safe. Okay, one more time. Goodness. 0 end is not equal to empty string. Oh, is that true? I think that's what I'm saying now. Oh dear, is that what I want? Yeah, I don't know if the cleverness is getting me here. Okay, so now this is coming up 0 end. So I said if anybody ever asks you for a line they don't have, before I just returned an empty line, which maybe is no, I need that somewhere. Um, hmm. Maybe the get is still correct with that. It if you don't have a line, it should be empty. I think that's true. But I think this 0 end thing that I was trying to get from here, maybe the 0, maybe what I should be saying it should say is it's like this. Um, then this stuff can yeah, let's try that. I think this 0 end thing is junk. I think it's going to be on the caller to say if there's no valid line number, then pretend it's 0 end or 999 end or whatever. Okay, let's get our last things here then. Unknown line, next line number is 0 end. Line after. I think what we're saying is if you ask for whatever's after line 10 and there is no line 10, you should get a nil. Okay. And if you ask for this one, you should get a nil. And this one, you should get 20. Okay, so I need to make my nil return values. So if the start index is nil, then nil. And if it's out of range, if we're falling off the end, return nil. All right. I think that will make program back a good. But you've heard me say it 3 times now, at least, so, hard to know. Yay. Okay, and then the rest of the tests, I don't know where we're at. Okay, we're still good there. All right, so let's make program knows line after current line. or given line. Okay, and then our interpreter. Now this, I want to say, I want to say A equals program.line after line number. Okay, but I think I'll get a type conflict from that. Program.line after line number. Okay, line number can't be optional, and yeah. If you fall off, okay, but we have to be careful because if, let's say the last line is GOTO 10, okay, then the fact that there is no line after is not a problem per se. Now, like I said, I think the old basic, so this is like the 1964, so what does that make it? 58, something like that. Okay, it's old. An example, line 3, page 3. Okay. Yeah, so they say end there. I think they explain everything. Let end. Okay, they executes an end statement. All programs must have an end statement. It must always be the higher numbered statement. End be the highest statement. Okay. So in this version of BASIC, you just have to have an end statement there, so you never can fall off the end of the program. In these other ones, they don't require it. I don't know if we can get to an example, but I think it would be full of examples. Okay, here's one. There's data. There's no end statement. That it got. I don't even know if it accepts an end statement anymore. This one, 6502 basic, has the end statement in its keywords, so it does accept it. This one probably does, but nobody used it. So what does that mean we got to do? Well, I think yeah, somehow we need to synthesize it somehow. So if this line number exists, see, I want to make like a synthetic one, you know, that's like 9999. Or maybe line 10,000. Maybe we just say you can have lines up to 4 digits. Oh boy. Okay. It's just finding the right way around this. And really, there's even more room to play around. And I don't know if it's just being clever, but if ints in Swift are 64-bit ints, ints in BASIC, they don't really exist. But when they well, usually it deals with floating point numbers, but if it plays with ints, it only goes up to 32767, or 32767. 16 bits. It would allow negatives, but only positive, max positive. So I know I could put 99999 and be fine. And maybe that's what I should do. Maybe here. Okay. I'm going to put 999. That's too big for a basic int. Okay. So I'm saying that implicitly there's an end statement up in the way high range. Okay. And we can take advantage of it. Okay. And so, but like that number, I don't want it to be 0. Maybe this is what I want. Maybe I want this high line number. If you look it up, okay, I got to distinguish things. If you look up a line and it's not there, it comes back blank, okay? But if you ask for a line after either a non-existent line or the last line, well, it does. You can't even get the last line, right? Because theoretically they won't ask for that number. But if you ask for one after the last line, it returns nil. I'm gonna make this. Boy. All right, let's do this. Let max line number equal 9999. Okay. And our default is max line number goes to, let's put it in here too. Why don't you like that? Prop initializer should run before self. Oh, okay. I hate to do this, but I'm putting the numbers all next to each other. Okay. Okay, so if you ask down here, okay, the get set is as it always was. If you ask for this, let's return max line number. This is going to be an int now. These are going to be program.max line number. Program.max line number. Int max line number. Okay, this thing should pass. Empty program says first line number is 0. Well, I think, okay, first I got my assertion backwards, but I think to say it is max line number, okay, so empty program says first line number is number. Okay. And that's kind of good too. Okay, so let's again make sure that's okay. And then back here. Okay. So now we always get a line number. If you ask for it, you'll get 9999 end. Okay. And I think that's probably consistent. It's a little slightly goofy. Okay. Um our all our tests pass. Is that true? Before I get too far down the line? No, it's not. Okay, list knows program. He's got the 999 in there, doesn't he? Yes. Same thing here. Okay. This is what you pay for these things. All right, list. Let's take the program. Oh, golly, I want to remove the max. Okay. Interpreter test. Okay. 10 go to 10. Okay, that's interesting. Oh. Okay. We parse. What we have is 10 go to 10, which now implicitly has an end statement. You create the program. The line number should be 0. Why is that not true? And then you step and you should be line 10. Okay, so interpreter create program. Let's see that. Line number. This first line number. Why is that not 10? Why is this the only test that thinks that's a problem? Most of them don't assert anything. Actually, no, this is correct. It should be 10. When you have program line 10 go to 10, then the first one should be 10. I believe that's correct, actually. Oh. This. Yeah, okay. This is a consequence of trying to run step with parse. Because we pass in the program, but we don't use it when we parse, so we're lying about what the program is. Let's try this. I think we may be better positioned now to do it, or maybe we just have to not lie about the state of the program. That's probably more accurate. That it equals 0, that was really not true. It should equal the first line in the program. And that's where the 999 whatever came from, because it assumed it had that default line was the only line when really we want parse line 10. I think, yeah, let's see if this works. I believe we're telling the truth now. It won't be a problem. Okay. And this is a little artificial because the program, right? 10 go to 10 is like infinite loop time. So We only test one step. That's the kind of compromise there. Eventually we'll have a break or something like that, and we can get out of those loops. All right. How are we now? Okay. Golly. All right. But what we've done is program knows the last line, knows the next line for any line, has a default end at the highest line number. Okay. Now I think we're maybe positioned. Okay, so this is legal now. We can say get the line number after the current line number. Okay, and while not done, all right, let's go back to the loop. We're going to get the line number. We're going to figure out the next line number, parse that line, run the step. If it was a GOTO, it's going to overwrite line number. If it's not a GOTO, it's going to be the implicit next line. We'll come back in here and look up whatever that line is, which could be an end. Okay. I think this will pass everything. Maybe one failure. We might have commented out a test too. Where's interpreter tests? Okay. No, we still kept that. Okay, good. So now two-line program runs both lines, 25. So line 25 executes. It says next line is 40, executes 40, 40 sets the done flag false. Next line is 9999. So it would still terminate eventually, but it terminates after line 40. Okay. Let's make this a touch more sophisticated. We can't use our go-tos in these tests because, well, I guess we could, right? Okay, let's do it. Let's this is run multi-line program and fall off the end. Okay, so let's go to 50, 30, print 30, 50, print 50, 99, and we'll fall off. Okay. 50, so this should jump forward and print 50. So our output should be 50. Okay. Not a super realistic program, but legitimate. And it does test our GOTO without an infinite loop, so that's something. All right. I think we handle multi-line programs. Fall to next line, or GOTO, or fall off the end and stop. All right. Now, let's see. Run. Let's clean up some. Okay. So our run. Oh, sorry. Okay. I'm still not happy about output, but we get the line number. We find the fall through line number, do our parse. We got to do this before we run step because step might change line number. Okay. That's good. These are getting long. I don't know. I don't quite feel the urge to break out anything at this point. It's not amazingly horrible. Let's see. To do text. Run multi-line programs. Yay. All right. If statement, expressions with variables, expressions with functions, expressions with subscripts. There's so much to do with expressions. We haven't even dealt with strings. And I guess we got to do string expressions in here somewhere. Okay. All right, let's go look at if. So I'm going to start with the simple version. This is probably yeah. Basically, the original one. Let's see if we can find the statement by statement definitions. Yeah, back then, here's a picture of a keyboard because it's just not that familiar. Well, a teletype keyboard. Yeah, it's funny that, okay, this is summary of statements. Go to if then. All right. So in those days, in the original BASIC, you had if expression, relation, expression, then line number. This letting you print something, that's a later thing. And notice it has this colon. You can actually put multiple statements in here in the semi-modern ones. I don't know. The ones 20 years of evolution got you this. Okay, that's what I want to say. But we'll start with this form. So if then implicit GOTO, and then later we'll deal with the fancier one. Okay, so if relation expression then line number. Okay, or if relation expression then statements. Okay. And I honestly care less about that one. I don't know if I can find, let's see. There's this old program, The Amazing Maze, that was in that basic computer games book way back when. And thought I had a picture of it here too. I don't know if I can pull this usefully. Did it pull it up? Oh, broken link. What happened? No, I'm gonna have to figure out that link. Okay. Well, let's search more generally. Amazing Maze Basic. What's cool about this program is it generates a pretty cool maze. Any grade level. The mazes are okay, but let's see. Oh, let's try basic computer games. I don't know if that might be it. Yeah, here you go. I would like us to be able to manage this code. Okay. What's weird about this program is almost every line is either if something goes somewhere, or initialize a bunch of stuff. Okay. And it's incomprehensible in its current form, I think. I don't see how you could ever possibly, can't believe they wrote it in the first place, honestly. But You can see in here random 1 times 3 plus 1. So it's picking a few choices. And I think there's another one, 1 times 2 plus 1. So it's got a couple places where it generates a choice. But when you look at this, I mean, that's a darn good maze. It's certainly amazing that you got that out of this code. All right, but there's not much sophisticated here. We don't do so. If I inventory, what are we missing? Well, we don't have this tab notion, and we don't have printing strings. Okay, we don't do multi-line statements. We don't have an input. That we can do. We don't do dim. We'll have to do our arrays first. Well, here's our if statement. That's enough to do that if we had our array stuff. On x GOTO. Okay, so it looks at x being 0, 1, 2, I guess, or 1, 2, 3, and chooses which target to go to. Int and rand, those functions, a little more sophistication there. But we're not that far away. I mean, I would say, I don't know, we're probably halfway there or more. Okay. And I would love to run this thing, and our interpreter runs this and spits out this. It'd be like, oh, cool. But yeah, we got a ways to go, but it's not impossible. Oh, they've got 4 next in there somewhere too. I see a next J, next I. So there's a couple loops here, and they're printing out stuff. Okay. And I think, yeah, so that's my goal, is to be able to run programs like this. I mean, this one in particular has got a fond memory because it generates such a cool maze for such random looking code. But if I can interpret this and spit out a maze that looks like that, I'd say, yeah, that we've come pretty far in this thing. But well, it starts with this if then. Okay, I don't see any if. Oh, here's an if at the end of a line, so that colon. But I don't see any ifs that do if and print. Okay, so they're using a kind of restricting themselves to a more simple version of BASIC. Okay. Let's see. So if relation line number, and then if relation statements. And do we say then in that case? If then, yeah, we do. Okay. And notice there's an ambiguity here we're going to have to resolve too when we get to these multiple statements, right? If x equals 5, then is it then and then print x, y equals z? Or is it if x equals 5, then print x, otherwise do y equals z? Well, it's the first one. There's no sort of else clause with this. But you could nest them, then print x if y equals z, then y equals w. So we got to worry about that at some point. Okay. We're due for a break. Yeah, it's a mess. It's just, I don't know. It's just so crazy to me because like every line is just like test something, branch somewhere, test something, branch somewhere, generate a random number, branch one of random places, and so on. I made a refactoring exercise out of it. So like phase 1 is just kind of turned into a structured program so you can see what the heck is going on. But once you do that, you can bring out more pieces of it. I still don't think I would have been able to create that algorithm. And I bought Jameis Buck has a book on maze programs from pragmatic programmers. I bought it and it's kind of sitting on my Kindle at this point, but I keep wanting to look and see if that maze is in there, that style, because I know he does a bunch. But anyway, we'll take a break, like 3-minute break, come back, implement this if line number. I hope we can do that in the next 45 minutes. I think I'm going to push this one down since I don't need it for the maze. Let's see if we can get the maze. Oh, there it is. Okay. Yeah, I did push it down. Okay. So anyway, I'll take a 3-minute break. All right, welcome back. Okay, so we're going to start the way we do every time we start a new statement we want to support. We're going to start at the lexer and make sure we can handle the syntax first, just from a token point of view. We've got the if keyword. I couldn't just use .if because if's reserved. And we already have the then. So the lexer handles the stuff it has to do. The relational expression we handle, and line number as an integer. Interesting. I don't know what we'll get there. I guess we'll have to see how that works. Looking for line number true is at the beginning of the line, if you remember how that bit worked. Once you find it, we just say, no, you're no longer looking for a line number. Okay. So I think we'll be getting numbers back here. It's an interesting one because I guess, yeah, it would not be legal to have a number right after, sorry, the only legal number after a then is a line number. And an expression wouldn't be legal there. You could do an assignment, but you wouldn't have a number on the left-hand side. Okay. So maybe we're not done here. We are looking for a line number. The problem is if what will set that false, it's like I only want it to be true right after a then statement. Yeah, this is tricky. Okay. We did something like in when we handled RAM, right? Keywords and names. That's down here. Well, where is it? I just bumped something. Okay. Keywords and names. This thing. All right. We find the reserved word, and then we did some work. If it was a rem, we skipped forward until new line. I think we're gonna have to do the same thing with then. We're gonna peek. Maybe it's not an issue for now, but after then, I think you are looking for a line number. But if it doesn't start with a number, yeah, I think maybe that's the case. If what you see is a digit, you want looking for line number to be true. Okay, yeah, this is old school language before they really got going on the grammar stuff. Right. So I think if you see a then and the first thing after it is a digit, then this is the correct code. We want to find an integer. If it's not a digit, then we don't want to. Okay. So let's encode that understanding. And it's actually jumping a little bit ahead because it's more like the then print case, that we're guarding against. Okay, tested end in a line. Number, first token, remark. Okay. I guess we'll put it down here, but yeah, so all right. So let's find a sample we want to emulate here. Mostly check tokens. This is probably the closest case. Okay, so we're going to parse then 9. Okay, so token 1 should be then, and token 2 should be integer 9. Okay, so that Lexer tests, let's just run those. That should fail. Oh, so, oh, we got to do the line number first. Okay, so this should be integer 20. This should be then. Sorry, just then. This should be integer 9. Token 3. Okay. So the reason it didn't fail was because we always start off expecting a digit line number, and so the first first digits on the line are interpreted as a line number. Now we're saying, okay, get the 20, and this one I expect to fail. Yeah, I can't even get my failures when I want them. Sorry, integer 9. Okay, and we're expecting a float. Right, number. Okay. Yeah, so we match the then okay, but we need to do this kind of thing. Okay, so if let's make one more test. I want to test both ends of this. Okay, then followed by print digit gets number. Okay, 20 then. Oh, are we handling this or not? Print 9. Okay, 20, then print token 4 should be number 9. Okay, both these tests should fail. Oh, this one's okay. Oh, okay. I guess that should be okay. I wasn't sure it would catch then print okay, but it parses the integer and then it says, okay, everything else on the line must be must be a floating point number, and so that sticks. All right. So I think what we have to do Okay, we get the word index. Okay. If keyword equals mark, else if keyword equals then. Okay. And I think what we're saying is if the next character is a digit, let's see, which I think we have a helper for that. Well, we have repeat any. We don't want to repeat. We just want to peak. Substring start event, ending event. Well, I don't think we have anything directly that. Okay, let's just. Yeah, these do repeat any's. Okay. Well, if program subindex is greater than or equal to 0, and program subindex is less than or equal to 9, in other words, it's a digit, then we know we want, what's that thing called? Looking for line number equals true. Okay. If it's not, then we're back to that then case. Okay. So I believe this is going to make this test pass. I think we squeezed out all the spaces, so it should work. All right. And just to make sure, yeah, let's put spaces in just to be extra careful. Okay, so we've got then token set state, so we get a line number if digits immediately follow then. Okay, yeah, so we have to do a little peek ahead, extra peek ahead. Okay, so anyway, we have a lexer. It handles if and then, and we need to do a parser. Let's use our parse. Well, we don't have one yet. We need an if. I forget. Can I do backtick if? Oh, do I want to do that? Ugh, that's so ugly. I don't know. Maybe it's not ugly. If, and it's going to take an expression and a parse. Well, no. In our case, it's just going to take an int. Okay. Expect that identifier in enum case. Nope. Okay, it likes it. All right, so I'm being a little weird. It's weird to me, but it's legal Swift to put the backticks and use keywords. In the tokenizer, I said if keyword, and that was the only one that says keyword. Like, yeah, okay. At any rate, if you are going to parse an if, you're going to have an if, it's going to have an expression, and then it's going to have an integer that's the GOTO part of it, okay, that we just made sure we could get. All right, and We may, if I build, somebody may complain, yeah, the interpreter needs a default case. Okay, so if nothing we care about, well, I think we can. Oops. Okay, just something to tag us a little bit. All right, build again. Output is okay. Well, let's just return this. We really don't care. We just want to get out of it. All right, one more build. All right, that was heavy. All right, so we want to do the parse for this, and I think we'll just take this for a model. As I don't know, I keep saying I got to parameterize these things. Maybe I should get on that one these days. Test if, then go line number. Okay, so if we say 42, if 0 not equals 0, then 42. Okay. Actually, I'm just going to simplify it. If 0, then 42. Okay. Parser.line. Oh, we don't want that one. We want one that actually does something. Okay, so we expect line 42 dot if with I need an expression number 0 an integer. Let's make it different. Just to make sure nobody's tangled up in here. Cannot infer reference to member integer. Really? Because you would think, oops. Type int. Oh, right. We just need the bare integer. And then now can you infer this? Maybe. Okay. 42. If 0, then 43. Okay, so an expression, it gets evaluated. And if it's 0, if it's not 0, then we do the thing. Okay, and we should parse this tree, and there should be no error messages left over. Okay, good. Skip is not equal to line 42. We just do skip when we don't know something. And unknown statement. Okay. Parser. We got single line statement. Okay. So there's where that error is coming from. Case.if. Try if then. Token. Oh, right. This is if keyword. This needs to become. Okay. So we're looking at the if, we see it, we go next token. Okay. Now we have an expression. Try. Okay, after that, we require the keyword if, then. Oops. Oops. Expression. Well, at the end, we're going to return dot bang bop if of expert and line number. Target. Okay. We do this. I'll just say next token consume then, but we need to check it. That should be an error. Okay, we'll consume the then. Let target equal, well, if case took, no, dot integer let target equals token, then return this. Else return, well, let's just say throw. Somebody must do this. Yeah. We're just throwing junk at this point. Okay, so we skip over the if, we try to find the expression, we skip over the then, we make sure the target is an integer. If it's an integer, then we just return the expression in the target, and otherwise we throw this wrong exception. So we got two places we got to make sure. Okay, and this should pass. Okay, what's skip is not equal to, well, what was the error message? We still got extra characters at end. Oh, we didn't consume our token. Okay. That doesn't help this any. Oh, right. Okay, so let's get these two errors in there as well. If missing, then gets error. Well, let's do if zero print. How's that? Okay, if I did the 43, then it would just make it one big token there. Okay, so I don't care what the result is because I'm getting an error message, so I'll ignore this. And my error message should contain parse error dot missing then. Okay. And this should fail because we don't handle the error message yet. Okay, we fall through to that other expected start of expression. Okay, if I thought I had an expected thing here somewhere. Let's make sure. Require. Yeah, we want to require then. So require then. And the error is this one. Can I just say this? And I gotta find an example of require because I don't think did it consume the token? No. Okay, so we require then. Okay, next token. All right, this should pass. And then the next error. If then missing target gets error. Okay, 42 if 0 then I guess that would be a missing target. Okay. And this is a parser test. Should fail. Should get the wrong one. Yeah. Okay, so if case integer, we get the integer, we take it. Otherwise, we get a missing target. And run everything. All right. Parse if statement, checking for missing then or missing target. Okay, so that's not bad. All right, now our interpreter. Okay, so our parse says if expression int, and our interpreter has to do something with it. Let's return do if then. And this is let expression. Let target. Okay, and we don't have a method like that. You're not offering to create one, are you? No. Expression and a target. Okay. So this is a lot like the GOTO, right? It's really just embedding that test. GOTO. Right? So line number equals target if the whole condition holds. Okay. So we got to evaluate the expression. Print output equals values map format. So we have to call evaluate. Okay, so we'll evaluate the value. Evaluate expr. If the test is not 0, then we'll do GOTO. I just did that with no tests. Let's comment this out. Okay. That's what we had before. Did we pass output in? Ugh. Yes, we did. Okay, test should pass. Okay, let's do an if test. if with false result. If 0, then 50. Okay, 0 should be false, so this should print 30, 50. Let's make 50 an end. No, let's do it like this. Okay. So if 0, then 50, 0 is not true, so it should just fall through to 30, print 50. Okay. And interpreter tests. This will fail. And because it's a Boolean, it's almost better to put both tests in at the same time, really. If with true result, does GOTO. Okay. False result falls through, and true result does GOTO. Okay, so this one should just print 50. All right, and it's okay that the first one passed. Oh, wait. How does this work? If 0, then 50. Oh, I want 1. And I want to say test, so I get a test. Okay, this one passes because the if does nothing and it just falls through anyway, because all it does is output. This one should fail. And I want them both there because I don't want to do some sort of flip-flop thing where, the one test passes and the other one doesn't. Okay, so I think the code I wrote is probably correct. We make a test, evaluate the expression. If it's not 0, then we do the GOTO, and otherwise we just fall through. And interpreter tests. And those should all pass. Okay, so interpreter handles if then true or false results. Cool. Oops. And let's appear to do if relation then line number. Okay, we've got that one. I'm going to move this around a little. It's one thing to use variables, but it'd be nice to assign them before we worry about functions or subscripts. And actually, I think subscripts are maybe more important than functions for what we're doing. Okay. If relation expression, then statements. Yeah, we're going to have to do the multi-line, multiple statements on one line. Do we say that somewhere? Okay, let's probably before, maybe. Yeah, back to statements. I'm sorry, expressions. They're just so, it's kind of amazing how much complexity is in those when the rest of the statements are all pretty simplistic. Yeah. Okay. We will pick up there next time then. I think getting the the expressions more done with variables and assigning them. When we introduce assignment, we're going to introduce more state to our interpreter, right? We have to maintain, I think we'll use a map, or a dictionary of variable names to their values. And the variable lookup should be using that. Get these done. I think that does numerical expressions. That will finish that. Although we have a def that can make its own functions, so maybe there's a little bit more to do. Yeah, but we'll pick up there next time. I'm assuming we'll pick up and finish these two. So same time tomorrow, 9 to 11:30 a.m. Central Time, 10 to 12:30 Eastern, and I think it's 3 to 5:30 UTC. Rick, I think you said you were in the UK. Maybe you can correct me there if I'm wrong. But yeah, I think we'll at least hopefully get those two done and maybe make a dent in some of these, and yeah, move on. I mean, we're chugging through. Some of these come in pretty quick. That if wasn't too bad, and the end wasn't too bad. So anyway, yeah, oh good. I always check these things, and it's still easy to get wrong. Anyway, have a good evening, and hope to catch you in the future. Bye bye.